Good morning, students. Today we can see the about conformal mapping and bilinear transformation. First, let us see the definition for conformal mapping. We call a mapping W equal to f of z is said to be conformal. A mapping if f dash of z not equal to 0. By formal definition is a mapping W equal to f of z is said to be conformal at the point z equal to z naught if f dash of z naught equal to 0. A point z naught at which the mapping W equal to f of z is not conformal is called critical points. Is not conformal is called critical points. That is dw by dz equal to 0. That is dw by dz is equal to 0. So this one we call it as a critical points. Next we can see one example how to find out the critical point for the curve w equal to z squared. What are the critical points? First we differentiate with respect to z. So dw, one second, when you differentiate with respect to z, dw by dz is 2z. So when you equate to 0, z equal to 0. So therefore z equal to 0 is called the critical point. Z equal to 0 is called the critical point. This is how you find out the critical point for a given curve. Next we can see what do you mean by conformal mapping. So here you are going to find out the image of the region. Let us see one problem in this type. Find the image of the region y greater than 1 under the transformation w equal to 1 minus I into z. Now you are going to find out the image of the region for y greater than 1 under the transformation w equal to 1 minus I into z. So z equal to x plus iy and w equal to u plus iv. Just we have to substitute, put w equal to u plus iv and z is equal to x plus iy in the given transformation. So it becomes u plus iv equal to 1 minus I into x plus iy. So now multiply. So 1 into x plus iy is x plus iy minus ix and then plus y. I into I square is minus 1, so it becomes plus y. So now you separate the real part and the imaginary part. So x plus y plus I into y minus x. Now your real part is x plus y. Real part u is equal to x plus y and the imaginary part v equal to y minus x. Now you have to find out u plus v because it is given that when y is greater than 1 you are asked to find out the image. So now you add both the equation. Adding both the equations, u plus v equal to plus x and minus x will be getting cancelled and y plus y becomes 2y. So what is y here? Your y is u plus v by 2. Now it is given that when y equal to 1, what is the image? So what is the value for y? It is u plus v by 2. U plus v by 2 is greater than 1. So u plus v is greater than 2. So this is the image. Now we are going to draw the diagram in w plane and z plane. So let us draw the diagram here. So now x-axis and y-axis. So as already we saw that the w plane consists of u and v. So x and y in the z plane, it has in the z plane. So we are asked to find out what's the value, that is when y equal to 1. So let us take this point as 1, and when you draw the diagram, and this is the point y is equal to 1. So greater than y greater than 1 means this is the portion. So this is the portion region y greater than 1. Now we are going to find out the image in w plane, and w plane consists of u and v. So u plus v is greater than 2. So here when the point is 2, 0 and 0, 2, it cuts. Now you join these 2 points. So here this is the region where you have u plus v is greater than 2. So the image of y greater than 1 in the z plane is transformed into the region u plus v greater than 2 in the w plane. So this is how your conformal mapping is done. Let us see one more problem in this type. Find the image of the circle modulus of z minus 1 equal to 1 in the complex plane. Under the mapping w equal to 1 by z. So here the mapping is w equal to 1 by z. What is z? Z is equal to 1 by w. So what is the equation of the circle? You are asked to find out the image of the circle, no? So the equation of the circle is modulus of z minus 1 equal to 1. Put z equal to x plus iy. So x plus iy minus 1 equal to 1. So when you separate it, x minus 1 plus I into y equal to 1. So what is this? So this one is a circle, x minus 1 the whole squared plus y squared equal to 1. And what is this one? So here it is, when you expand it, it is x square minus 2x plus y squared equal to 0. I can cancel 1 on both sides, so it becomes 0. So here you have w equal to u plus iv and z equal to 1 by w, that is 1 by u plus iv. Now you multiply and divide by the conjugate. So u minus iv by u minus iv. So z is x plus iy and u minus iv by, in the denominator when you apply the identity u plus, that is a square minus b square, a plus b into a minus b, you will get it as u squared plus v squared. Separating the real parts and the imaginary parts, you have x is equal to u by u squared plus v squared, and y is equal to minus v by u squared plus v squared. Now substitute this one in the equation 1. What is that equation 1 means? You can take this as equation 1. Substituting the value of x and y in 1. So it is u by u squared plus v squared the whole squared minus 2 into u by u squared plus v squared plus minus v by u squared plus v squared the whole squared equal to 0. So now when you take the LCM, you will get it as u squared minus 2u into u squared plus v squared plus v square equal to 0. Taking u squared plus v square as commonly outside, you will be having 1 minus 2u equal to 0. Since u squared plus v squared is not equal to 0, you have 1 minus 2u equal to 0. So that is u equal to half, or 2u minus 1 equal to 0. So what is this one? 2u minus 1 equal to 0. It is a straight line in the W plane. Now we are going to draw the diagram for this one. So for the in the Z plane, you have x-axis and y-axis, and it is a circle with center 1, 0. Radius is 1, 0. Sorry, center is 1, 0 and radius is 1 here. Now in the W plane, it is a straight line. The image under the transformation, it is mapped onto in the W plane as straight line. So it is u is equal to half. Okay, so this is how you map the conformal mapping under the transformation W equal to 1 by Z. Thank you, students.